Noise and vibration hazards. Physical hazards are the factors within the environment that can harm the body without necessarily touching it. Physical hazards includes noise, vibration, radiation, pressure, and thermal stress. In this topic, we are going to look specifically on noise and vibration hazards. The modern workplace can be noisy, which poses two safety and health related problems. First, problem of distraction, as the noise can distract workers and disrupt their concentration, which can lead to accidents. Second is hearing loss when being exposed to the noise that exceed prescribed levels. This can result in permanent hearing loss. Thus, we can say that noise is referred to any unwanted sound. Modern safety and health professionals need to understand the hazards associated with noise and vibration. First, let's identify the limits of the noise. Note that the unit used to express the intensity of the sound is called decibel. 0 to 20 decibel is practically only audible under laboratory conditions. 20 to 30 decibel is the ambient noise far from towns and roads with no strong wind blowing. 40 to 60 decibel is a normal volume of a conversation. 60 to 65 decibel is a moderate volume of a television or a radio. 70 to 90 decibel is the level of noise for a city traffic. 100 decibel and more can be represented by the noise made from the disco or pneumatic hammer. For up to 130 decibel, it is equivalent with the sound of a jet engine at a distance of 100 meter. Note that exposures of less than 80 decibel may be considered safe for the purpose of risk assessment. The risk from being exposed to the noise that exceed the prescribed standard level of noise are temporary loss of hearing or permanent hearing loss, and tinnitus or ringing in the ears. Tinnitus usually goes away, but in severe cases, it may not causing an additional problem. The remedy are eliminate the source of the noise whenever possible, find other alternatives such as quieter equipment to use, insulate workers' area from noise produced by the machines, reduce the amount of time spent in a high noise environment, provide hearing protection, and provide hearing tests for workers to establish any loss of hearing attributable to the work. As being discussed, the fundamental hazard associated with excessive noise is hearing loss. A number of different factors affect the risk of having loss associated with the exposure to excessive noise. The most important of these are intensity of noise that related with sound pressure level, type of noise such as wideband, narrowband, or impulse, duration of daily exposure, total duration of exposure, the age of the individual, coexisting hearing disease, nature of environment in which exposure occurs, distance of the individual from the source of the noise, and position of the ears relative to the sound waves. From these various factors, the most critical are the sound or noise level, frequency, duration, and distribution of noise. As we know, exposure to sound level below 80 decibel is generally considered safe. Meanwhile, the unprotected human ear is at risk when exposed to the sound levels exceeding 115 decibels. Note that prolonged exposure to noise levels higher than 80 decibel should be minimized through the use of appropriate personal protective devices. To decrease the risk of hearing loss, the exposure to noise should be limited to a maximum 8-hour time-weighted average of 85 decibels. In identifying and assessing the hazardous noise conditions in the workplace, it may involve with conducting periodic noise surveys, conducting periodic audiometric tests, record keeping and follow-up action. Audiometric tests. Audiometric evaluation is crucial to the success of the hearing loss prevention program in that it is the only way to determine whether occupational hearing loss is being prevented. If the comparison of audiograms shows temporary threshold shift, such as a temporary hearing loss after noise exposure, early permanent threshold shift, or progressive occupational hearing loss, then it is the time to take swift action to halt the loss before additional deterioration occurs. Because occupational hearing loss occurs gradually and it is not accompanied by pain, the affected employee may not notice the change until a large threshold shift has accumulated. However, the results of audiometric tests can trigger changes in the hearing loss prevention program more promptly, initiating protective measures and motivating employees to prevent further hearing loss. Audiograms are recommended to perform on the following occasions for maximum protection of employees: pre-employment or prior to initial assignment in a hearing hazardous work area, annually as long as the employee is assigned to a noisy job environment for a time-weighted average of exposure level equal or greater than 85 decibel, at the time of reassignment out of a hearing hazardous job, and at the termination of employment. In addition, it is suggested that employees who are not exposed to be given periodic audiograms as part of the organization's healthcare program. The audiograms of these employees can be compared to those of the exposed employees whenever the overall effectiveness of the hearing loss prevention program is evaluated. In an optimally effective program, the two employee groups should show essentially the same amount of audiometric change. There are three components of a noise hazard: noise source, noise path, and noise receiver. Noise source can come from the unbalanced rotating equipment, mechanical shock between solids, friction between metal parts, and vibration of large plates. Guidelines for control of occupational noise has been developed by the Department of Occupational Safety and Health Malaysia that provide basic practical guidance to the employer in developing noise control measures to comply with the requirement of the Factories and Machinery Noise Exposure Regulations 1989. These objectives can be achieved via stimulation and enhancements of the conceptual understanding on the occupational noise control and its subsequent implementation, specifically in Malaysian workplaces. Noise can be reduced by engineering and administrative controls. The most desirable noise controls are to reduce the noise at the source. The second priority is to reduce the noise along its path, and the last resort is noise reduction at the receiver using personal protective devices. Again, the use of PPE should never be substituted for the two former approaches. Note that the noise made from most of the equipments are mainly due to the waste energy. Generally, reducing the noise at the source offers the most options, such as by enclosing the source, altering the acoustical design at the source, substituting the equipment with less noise-produced equipment, or even changing the process so that less noisy equipment can be used. For reduction of noise at the path would generally involve with adding sound-absorbent material or moving the source farther away from the receivers. Reduction at the receiver may be achieved by removing the employee from the sound field, enclosing the worker, limiting the worker working period in the work schedule so that the time of exposure is reduced, or through the use of hearing protective equipment (HPE). The mode of attack to tackle occupational noise hazards are similar to the method for controlling any hazard in the working environment. The use of any appropriate control measures, including change in the plant design and layout, substitution to less hazardous work method, reduction of the hazard at its source and its path of transmission. It has been proven helpful to follow structured method of analysis so that no possible control measure is overlooked. Thus, the recommended approach are according to this outline: plant planning, substitution, and engineering control. Control by plant planning. It is important to consider the following: the building's load-bearing structure, floors, and machine foundation should be chosen so that all noise sources can be effectively vibration isolated. Powerful noise sources should be enclosed by structures which give adequate airborne sound insulation. Building elements where there is a risk of sound leakage require special attention. Rooms where there are sound sources and where personnel are present continuously should be provided with ceiling cladding which absorb the incident sound. Offices areas should be separated from building elements where vibrating equipment is installed by a joint of elastic material. Walls and ceiling constructions, windows, doors should be chosen so as to achieve the required sound isolation. Mounting the noisy equipment on light or movable partitions should always be avoided. In open plan offices and large rooms where there are several office functions carried out in the same room, there must be a ceiling with high sound absorption, and soft carpeting on the floor is also beneficial. Control by substitution. Use quieter equipment. Some examples are given as follows: replace high-frequency propeller or axial flow fan with squirrel cage type blower, which emits noise of lower frequency. Replace high-speed fans or blowers with low-speed types. Replace gear increasers with turbine drives, which are usually less noisy where high speeds are concerned. Replace air ejector for removing parts from punch presses with a mechanical ejector. Replace a mechanical hopper vibrator with an internal pulsating diaphragm type pneumatic feeder, which will greatly reduce the noise. Replace pneumatic portable tools with electric tools. Replace a pneumatic riveting hammer with a hydraulic press. If an impact tool must be used, choose the smallest one capable of doing the job, and replace mechanical presses with hydraulic presses. Engineering controls. Engineering controls consist of facility and equipment adjustment, other than administrative and personnel protection strategies made to reduce the noise level either at the source or within the worker's hearing zone. Some of the examples for the engineering controls are reducing drop height and using rubber flaps to slow down fall speed and absorb impact. Converting fan noise from lower to higher frequencies, which results in greater attenuation by atmospheric air. Lowering sound power by replacing solid plate with perforated metal. Lowering the sound power by replacing a single broad belt with several narrower belts. Reducing wind tunnel noise by filling out cavities around rapidly moving parts. Reducing fluid turbulence by straightening flow pathways. Use absorbent muffler size for dominant frequencies. Isolating vibration by placing heavy vibrating equipment on inertial block with vibration isolators and dampers. And house sound blasting machine in a sound insulated machine room with a partial enclosure erected around the work area. Vibration hazards. Vibration hazards are closely associated with noise hazards because the tools that produce vibration typically producing excessive levels of noise. Some of the risks associated with vibration hazards are hand-arm vibration syndrome, which is a form of Raynaud syndrome that normally affecting the workers who use vibrating power tools as part of their daily jobs. Lower back pain is another reported disorder due to exposure to vibration. And in the long exposure to vibration, the workers are having risk to the lumbar spine and pain to the neck and shoulder. Some methods to resolve these hazards are modifying the process, redesigning the task or the equipment, buying machines or vehicles that are designed to reduce the vibration transmitted to the operator, improving and maintaining road surfaces, implementing a seat maintenance program to ensure vibration dampened seats are maintained in good condition, implementing speed limits, implementing regular work breaks, posture changes, or job rotation to reduce exposure time, and provide training, information and supervision on adjusting and operating equipment, including seats, to reduce exposure. The Department of Occupational Safety and Health Malaysia has issued a guidelines on occupational vibration to increase the awareness of the employers and employees about the effect of vibration to the human body and provide guidance to avoid and prevent the risk of vibration. According to these guidelines, vibration can be defined as an oscillatory motion of a mechanical system or body. The magnitude of vibration can be described by the displacement of this motion above some reference point, or alternatively by the rate of change of this displacement with reference to time.